a bit. Once I get confirmation of the recording starting.
This call is now.
Okay, the recording has started, and so as our custom, we welcome a few people. I think today I can see the whole screen for now, anyway. Welcome in a special way Katerega Peter. Tuwe ku MBs. We welcome Haifa Hafitha Karaoke. He has switched off his camera, but that's the reason I was saying. Kisiri Nyaboni, Maweje David. Kisiri Nyaboni has an interesting, it's called an avatar. You guys call it a profile pic. I don't know what most people call it, an avatar. Looks like a philosopher with an afro. Yeah, Navagenya, Jordana Chantal, Message Francis, Muhindos, Happy Edwin, Kwezi, Ronela Nambi, Paul Tuliahabwa, Dodwa Faruku, Timothy Wembabazi, Alionzi Lawrence, Ugola Ronald. Yep, so today we'll be talking about, we'll be answering a few questions about the assignment. I'll begin them in no particular order. Let me just check the chat. What? I'm going to complain about the Google captioning again. So the same that improved it. Maybe it's my voice. It's a bit subdued, but I think it will get better on. Okay, we'll begin with Jordana's question. Are people at a steady state? Because the screen is the same size and maybe they're not being shown. That's interesting. God. So, Message Francis, are you still not hearing anything? I've been I think I'd paused when, because I've been having a bit of a cold. So it's not, the audio is not on constantly. Okay. So let me just type, because if people can't hear, then. Um, let's see. Okay, we'll start with I usually call her Chantal. Chantal, I don't know. Jordana's question: should all groups hand in both superconductivity and lasers? I said you only need one of the assignments. However, if your group has for some reason done both, then you can submit them. So that one is answered. Then Alios Heroes is asking, should we submit both PowerPoint and Word document versions of the work? The primary submission is a Word document. However, there will be presentations which will be scheduled according to your groups. Because once we have the presentations, you'll need a PowerPoint. So, and if your PowerPoint is ready, you can go ahead and submit it. But we can create another submission for the PowerPoint towards the presentation. So you present to other groups. The idea is that every member of the group should have something to say. So, and everyone of the group should of course have a copy of the work. So that brings us to the other question. Just a moment. So the other question is, should everyone in the group submit a copy of the work? Yes, everyone in the group should submit a copy of the work. In case there's an assigned group leader, that's better, but I'll be considering, of course, the earliest submission of that group, the earliest person in the group to submit. Of course, you also don't want to be the last person to submit, but you might have like a day afterwards to also submit. Then the contributions. Yes, some people may not send in their contributions early, but in case they are available, then they'll also be submitted. Because especially I have people contradicting themselves. Okay, people I said could work on the same thing, but I don't expect everyone to have the same contribution. Yes, but the challenges and what those you can submit personally. So of course you submit. You also write a paragraph or two on how you solve those challenges. So the challenges should be related to the work mostly. They could be related to how you set up how you are communicating with the group or something like that. But if it's something about, it would be something about bandwidth, but not really about cost. But I'll not limit that one a lot. So this is usually also a section under the stuff you're going to present. Under your presentation or questions. Usually we want to know what challenges you faced and how you overcame them. So currently the submission allows up to 3 files unless you're having a problem with it. But if you can put them in one file. So the submission is primarily Word document. So just take care of that. What is there? Have I answered all of them? I think I have answered all of them. Now, of course, it's group work, so I don't expect that some people did parts and then made a Frankenstein. I don't know if you guys know what a Frankenstein is, but that there was one of the scientists who attempted to use body parts from different people to create another, would I call it human being? And it's from the book of Frankenstein. I don't remember who the author is, but we can search for them. Um, okay, Mary Wollstonecraft Shelley. It's actually, I didn't know it was that old, 1818. But there are many movies which have been released related to Frankenstein. So you guys can be able to check them out and get the story. So I don't expect it to be like that. I think it was electrified to life. I don't know if that was. So yeah, I expect it to be as coherent as possible. Sorry, I'm trying to save it from the audio effects. Mhm. Yeah, so Frankenstein by Mary Shelley. Mary Shelley. I don't know why it's a popular. The whole thing of reanimation has been popular, but yeah, it was just to make the point. So the creature itself, actually, Frankenstein was a scientist, and then the creature itself ended up being called Frankenstein. The modern Prometheus. Let me just check if there are some more questions in the chat, and then we'll see what to do. Ambrose, which groups are you in? Are all of them in the same course? That would be unlikely. And have you been working with both of them? So you submit with the one you've been working on. I think there were some people who were enrolled to 2 courses and had given the general guidance on how to go about that. So you go with the one which what? Where your course is primarily. Yes, there's a communication also which came out in regards to exams about people getting IDs. I don't know, could people type 1 if they have an ID and X if they don't have an ID? So Ambrose has typed. He has an ID. So one, if you have an ID, X if you don't have an ID. I think we can do a quick poll to see. Okay, Benjamin has. So I'm not participating in the poll, so I expect about 18 responses. Okay, so about 15 anyway. Because some people might be having breakfast and they can't type. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So I haven't yet seen an X. I think those would be the interesting ones. No, type X, not accept. Unless, Timothy, I don't know what you're asking about. Just the letter X. Maybe I should get a robotic voice for and just do. Okay, so Timothy has no ID. So for those who don't have, and also Gora Ronald has no ID. I don't know what the issues were. Had you guys tried? Had you taken photos? Were there mistakes on your IDs? Simanyi. But the general communication is there was that letter from the AR, and that letter was saying that the place for taking photos is open starting today. Today we also, the finalists are starting the exams. So the finalists are starting. So let me just get for you that letter from the AR. Unfortunately, I can't post it in the chat. Let me see if I can share it. Share screen. So if you guys can see that beautiful screen, that's a letter from the AR. And that letter is, we can pin it there. So it is, it has the university header, office of the academic registrar. I don't know how the date went that far up, but it is what it is. It's headed paper. So, but it should be office of the academic registrar, then the date which is there, which is 13th. That should have been Friday or Thursday last week. It was on Friday last week, so maybe some people haven't yet seen it, or a number of you haven't yet seen it. And it's talking about examination permits and identification for students during the 2019-2020 semester exams. And then, so the first bit is first year students have been issued with Makerere University IDs for identification during examinations along with their examination permits. First year students who will not have been issued IDs by the time of the start of examination should use their examination permits. So one, that their IDs which were issued, and two, that in case they have not been issued, you'll use the permit. So there I would advise you to carry secondary identification. But also first year students are hereby expected to report to the ID card room at the Senate building to take photographs with their identity cards and examination permits. So that means if you have neither photo, if you don't have any photo, it is possible that your ID is not yet out, but if you've taken the photo, it will be on your permit. So I'll answer the other questions in the chat later on if I can, but so that is it. At least I think what's important here is that you should be able to take a photo in that ID room as soon as possible. So I don't know if Ronald was supposed to check on his own accord today. Maybe he can inform us. But usually for these things, the earlier the better. Yes, all students, finalists, and continuing students are expected to have paid all fees. State House sponsored students, unregistered, sorry, State House sponsored students and other students on scholarship should get permission to set exams from the office of the VC. Okay, scholarships. I think State House will probably get lists. So the same way to what we are submitting, State House usually sends a list, but people individually have their own copies. Yeah, for scholarships, I think depending on how they have been coordinating or if they need to write to the VC. Yes, all continuing students should present IDs and examination permits for identification. Postgraduate students, those are the ones masters and PhD, or those students who have graduated before, that's why they're called postgraduate. So postgraduate first year students have not been issued with IDs and examination permits due to the process of issuing ID cards to undergraduate students. I think those guys will have to come with extra identification, but there's usually few. Okay, no, it mentions here they're supposed to do postgraduate students in addition to the IDs, I think. Will you use their first year registration forms for identification during the examination period? Those ones usually have their copies usually have the photo, I think. Then all students except the postgraduate students should obtain their examination permits from the college registrars. So I don't know what that means. I don't know, but it seems to imply that students are supposed to collect their permits from the registrar. I don't know. I think we can get a confirmation from the guild because sometimes people are printing their own permits, so that last statement seems to suggest that. So just get feedback from in case the class reps don't have that, from MES or from any representative of the guild. Because I hadn't seen that, so I hadn't prepared reactions to it. But once I get the info, I'll let you know. And then okay. So that's it. Let me just check. There are some questions which came into the chat. Round is saying that majority of the biomeds haven't got IDs. Okay, so I hope they can be able to take the photos. Yeah, but I think we had exams last semester, so some of those bits should be able to help out. Maybe actually right now it is more important to keep your documents since I'm not yet aware of the arrangements for people to be on campus. So At the end of exams, make sure all your documents are kept properly. Recess. I think what Alan is asking is workshop practice. I don't know. Workshop practice will be done. There are arrangements which will be made for that. So apparently there was an issue with the central registration. Sorry about that. For the biomeds. So we'll just be aware of that. So you make sure you communicate to the exam coordinator, head of department, such that that information is what is available beforehand. Or to the dean of the school. Just make sure there's a communication from your Ronald. It goes a long way to help in having a better experience. Yes, I think we have addressed everything. There's a message here, which was saying that my voice has deepened. The first time for most people when their voice depends is a good thing. But yeah, thank you for those quick recovery messages. It's an allergic reaction, I think, from the messages from Kalemba. But I'm sure it represents every one of you. There's a presidential candidate called Kalembe, Nancy. No, this is Kalemba. Actually, Kalemba should be from the central Kalembe, and what is, I think, from the west. There are many variations of that name. So maybe one important change, there was a draft timetable being shared around, and let me just see what it was saying. It was saying what? It was saying that exams are starting at some point. The one I saw is labeled electrical first year. It was shared by one Israel. It is very much in draft form. Our exam should be on 8th December. 8th December 2018. What? No. Sorry, Monday, 7th December 2020. This exam should be starting on 3rd December. But next week we'll be having our presentations, so no worries. We are just left with the solutions of the Schrodinger equation. We'll do that on Wednesday. The new revised program. I haven't seen the new revised program, but seeing some memes saying that there are 3 semesters in 1 year, but I don't know if somebody has it, they can raise their hand. They can type and then I can let you share the screen. Let me see. Usually it's here. News, no. Online applications, recent announcements. Let me first check under recent announcements. Private, mature. Important dates for the academic year 2019-2020. Sorry about that, guys. No, this is old. Well, you can type in the chat, but yeah, it's let me check what's up and see. Semester dates. Orientation 2nd January. Semester 1, 9th Jan. Graduation week in April. Then you have a 1 week break. And then semester 2. And then the academic year starts in August. Oh wow, that would be interesting. That would be quite interesting. Let me see how to share this. I was sharing the screen anyway, so I hope you guys were able to see it. Semester 1 would be starting on 3rd Jan 2022. Semester 2 would be starting April, no, sorry, 1st May. And then semester 1 would be starting on 1st August. And then, yeah, so you'd have 15-week semesters in 2021. And then recess, and then, yep, it can be quite intense, especially for, well, for everyone, but especially for people going to 3rd year and people transitioning from 3rd year to 4th year. Maybe since they're continuing students, it's a bit easier, but I think it's a bit it's a bit of a gear shift for everyone, because I mean you have people who are coming in for 1st year who are just having a week apart, and that means there was a question about recess. Most probably it will be done on the weekends, so it might be quite busy weekend or Fridays, or I don't know, but it will be during during the semester time. Okay, but at least for the 1st years themselves, they would have it at the end of the year. I think there's a, I don't know if there's an 8-week period to enable that. And so people keep telling me they have been campaigning. Well, it's your right to campaign, but you should also be able to balance with your academics. So yeah, it's going to be quite some time for people who are, most of the continuing students, and yeah, I know you guys are not really concerned about this stuff, but for this stuff as well. Can we do something? We can look at a few questions on uncertainty. Oh yeah, so cumulative holiday is quite less, but Ronald, I can't answer that question if students will be allowed in the halls. Now, the idea is that finalists will have left by the time these exams start, so maybe, I don't know if that will be restricted to government students. That is most probably the solution to it. But I think I'm not competent to answer that question. It is just speculation from me. But as you're sharing the concerns, maybe you can also get some clarification on what that means. But I know first finalists will have left by 30th November, that is Monday, or they will be considered to have left. That is the last day. So I don't know if these other exams then start on 1st or they start on 3rd or 2nd. Simanyi bulungi. But most students, at least in Senate, are due to finish by 28th. Let me see who is enjoying the rain. Just mute them a bit. Yeah, so you guys are free to stay for, we'll just have a tutorial on uncertainty principle. Some of the most, okay, all of them are interesting, but there's some interesting questions in university physics. Well, these are examples, so I'm just looking for the first example, if it is here. No. Hey, hanga. Let me take it to paint. Sorry about that. We are looking at some question to do with helium. Just a moment. I have the voice but not the screen, so just make sure you pin that screen. Okay, so we're here. I don't know if the presentation is still on. Let me just check. This is a wordy question, so would probably, it is referring to a previous experiment, and the question reads that in the previous experiment, and that is really X-ray diffraction. So that is X-ray diffraction. So there was Bragg's reflection that which was calculated, and then this question is asking based on that. Nitandikira wano. Example 3-2. So let me just share it in another. So this question gives a bit of details, but a lot of it is the text details. And they were saying that in that diffraction experiment with helium atoms referred to earlier, a beam of electrons of nearly uniform speed of 1.635 10 to the power 5 centimeters per second was obtained by allowing helium gas to escape through a small hole inside a closing vessel to an evacuated chamber and then through narrow slits. So in parallel was then allowed to escape through a small hole in its enclosing vessel into an evacuated chamber, and then through narrow slits in parallel, rotating circular discs of small separation. These slits are ring. Sometimes better to have an image. So this is not your typical sketch, and most times in uncertainty, the sketch is important for you to get the context. So you have helium gas in some sort of vessel. That's what they are saying. And then in this, the E should look like a subscript. So this helium gas has a velocity of some V. Let's use the colors. V is equal to 0.6 to the power 10 times 10 to the power 5. Then it is escaping into an evacuated chamber. So I think this evacuated chamber is which has those slits. So these slits are rotating somehow. So just pay attention. The magic is not in a lot in the description. So then you have, let's first erase this. We'll fix our container later. So you have this crystal here. This lithium fluoride. Lithium fluoride crystal. So you have, I think you have a screen somewhere. So you have some sort of beam through here, and then diffracted by that. Diffraction is really like a reflection, but let's just indicate this as going through there. And then we'll have a screen. Okay, full screen. So the diffracted beam was detected with a highly sensitive pressure gauge. The usual crystal diffraction analysis of the experimental results indicated a wavelength of that. How does this agree with the, so if you're asking how does it agree, to what extent does it agree? Yeah, so anyway, go the zoom. Zoom. If asking how does it agree, or to what extent does it agree with the calculated, so you should, this is asking you to compare. So if there are no calculations, then you compare by words, what is expected versus what you have, and usually what causes the difference. So in this experiment, you needed some things, that is the mass of helium, and you also needed, so if you have the mass of helium, in that book they calculate it using something else. They use the atomic mass, which is grams per mole, and then Avogadro's number. So we need one mass of helium. So in that bit it was calculated, and it could also be provided. It's very close to what I would call Planck's constant. But it's 6.65 times 10 to the power negative 27 kilos. Kilos makes it sound a bit heavier, but 10 to the power negative 27 is really light. And so we're going to use de Broglie, since we're having wavelength, de Broglie. So how do you know that we're still talking about the helium atoms? They are the subject, so we are not. So sometimes you're given the width of the slits, which does not really, okay, it might, but it doesn't really matter. So lambda is equal to h over p. So with this, we can be able to calculate the wavelength. So wavelength lambda is equal to Planck's constant divided by wavelength by momentum, which is h over mv, and we are given a velocity here. We are given a velocity of here, what is called uniform speed. The only thing is that we need to convert that. Let's first substitute for Planck's constant times 10 to the power negative 34. Planck's constant is in joules seconds. We can check consistency later. So you have joule seconds, velocity is in meters per second, and mass is in kilograms. So if you take this up, it will be joule seconds squared, and then you know momentum. A joule is a force which is kilogram. F is equal to ma, which is kilogram meters per second. Mass is per second squared, right? I mean acceleration, meters per second squared. So that is joules. Then here I've forgotten to multiply velocity, which is meters per second. No, we did, sorry. So force is ma, but remember work done in joules is force times distance. So here you have times another meter. So this should cancel out. Kilogram should cancel out. Then you end up with what do you end up with? Should end up with meters. That is the meters. Then, oh yeah, this per second squared cancel out. So this joule was already defined with this expression. So you end up with meters, which is wavelength. And so mass, your mass was so this m is meters, not mass. This is just checking that the dimensions are correct, which we should have done quite a long time ago. But just to recap, you did dimensions in S1. Mass was 6.65 times 10 to the power negative 27 times velocity, which is 1.635 times 10 to the power negative. So it's 10 to the power negative 5 centimeters per second. So to convert that to meters per second, you multiply, you convert the centimeters to meters. So we can now divide in. So usually you'd advise that you do the divisions of these and multiplications, and then you treat the powers separately. So of course, since they are all powers of 10, these will add up. So this negative 27, once it comes up here, it becomes plus 27. So Oh God. So 34 minus 27, 27 minus 34 plus 7. So 27 and 7 gives you actually the 34, right? Because that is 14. So negative 34, negative 34. 10 to the power 0 is actually 1. It is not 10. So then you'll be dividing this to give you 0 point something. Sometimes there are people waiting to be admitted. 6.625 divided by 6.65. That gives 0.996. And then we're gonna divide that by 1.635, which gives you 0.60932. Times 10 to the power 0, which is just 0.6. 0.60932 meters. So that's what you have. So what was the calculated version of wavelength? Wait. Sorry about this. The velocity was a bit off. The velocity was to the positive 5. I don't know. So 5 minus 3. This was supposed to be something else. So we are changing it from negative 7 to 10 to the power 5 centimeters. So we reduce by 2, which is 10 to the power 3. So negative 7 minus 3. Okay, 3 minus negative 7. So that's going to be a factor of 10. So that will be times 10 to the power 10. So we're going to have a bit of rewriting to do so that we don't confuse the masses. So 10 to the power 10 is angstrom, but zero point 60932. It's up to you really write angstrom. So and then you can just 27 minus 3, which is negative 24. So 34 minus 24 gives a negative 10. Sorry. So there's a negative over there, negative 10. So that's the wavelength we have now. What's our so that's the wavelength we have. So what was the original one? The original one, unfortunately, here is not given. But from the text, that is a 1.35 difference. I don't know what they had previously. Let me check. Do they have? Do they have it? I think it was 1.65. No? So percentage. Is the percentage of the old. But it doesn't really matter for most of the things which times 100. So you get the old value minus the new value, or the magnitude of that if the new value is bigger over the old value. Or reference. Instead of old, you can use the reference value, which is the one you had. And then the new, you can call it the calculated one. So some people don't like old and new. So the calculated value minus the over the reference value. So I would advise that you always use the reference value, but either way, if you, of course, want a percentage shorter or greater or something like that, if you use new minus old over new, then you should also be able to explain that in at least a sentence. You don't just put a percentage there and you move on like you're in P1. So you just have a statement. Actually, most of these steps you should state what you're doing in all these steps. If you're expressing something as, or if you're substituting something, you should state. Some people just want to write, and so in this bit they had a 1.5% difference. So I failed to get the old value. Now let's go to Hugh and Young. 1, 2, 1, 2. What? 1, 2, 9, 9.
What was the reference?
You'll have to check an iceberg. I've not been able to see it.
Okay.
At least I've not been able to see it in this time. We are looking at another uncertainty, but this time from just a moment. So as we're looking for it, I hope people are reading, because as promised, we're supposed to have a quiz. We're still working on the modalities of that. But it will be there. But as I've said, your exam is going to be earlier, which is Monday, 7th December. And so you should be intensifying your preparations for that exam. Harmonic. No, I don't want that. Why? What have we done? I wanted uncertainty. Is it in chapter 38? It could be in 38. Okay, that's what the beginning of 39. Could this be? Line spectra. The font. Oh no, line 39, not 38. See. Jeez. Electric effect. Yes, Heisenberg uncertainty. Okay, let's see. Let me just share back this iceberg, the PDF, sorry. Present the PDF. Okay, I have like 8 minutes to do this number. Okay, we might need a few more minutes. You have to pin the what? The screen. Yeah. It is visible. Let me just check. Oh. Unfortunately, I don't have it here to look for it, but look for it and then pin it. Since we leave Google alone. What? Okay, here we go. So these bits, this book, of course, has how to answer some of these questions. So identify and set up, then use equations, then get your answer. You guys read through that. For most of those problems, it's the same thing. But I'm looking for questions around uncertainty. Oh, there's that question 38.17. Some lasers emit light in pulses that only 10 to the power negative 2 seconds in duration. The length of such a pulse, the length is, in terms of wavelength, is 0.3 millimeters. So can a pulsed laser be as monochromatic as light from a laser that emits a continuous steady beam? Yeah, so that is uncertainty in what? In time. So that's an interesting discussion question. We want to see uncertainty questions. Okay, yeah, they have separated them. In other bits, they are not separated. No, there are problems. So those section questions, they don't pull us. So let's look for something. No, we don't have data. We don't have data. This. Why would challenge problems? Let me look for some uncertainty questions here. That is Compton. And I just wanted automato using A is equal to HF. Wow, okay. But that is an interesting question, this. Because you need to realize that the energy is from the intensity. So you need to read through the question and see the conversion bit. So sometimes there are interesting questions which makes Compton with uncertainty or some other thing with uncertainty. So again, you should know what the different values are, then you try and calculate the difference. Try to look for uncertainty problems. No, Compton. This one is asking for kinetic energy, wavelength. When I see collisions, and then these are data. Where does son of man get? Let's just get from, just have some interesting uncertainty questions. Unless they are at the end of 39 now. So always people have tried to be clever because some of the topics are in these books. They just want to photocopy and say they are finished. That is a lot to your detriment. Removing birthmarks. Yes, uncertainty principle revisited. Yeah, they had to be somewhere here. Let's look for one with 2 stars. Not that the ones with 1 star are really simple, but you guys, this is not uncertainty. It looks like emission spectra. It is. Okay, let's just do this one. It doesn't look a bit like uncertainty. Nope. What are they asking in both courses? Compare. E is equal to h over lambda. You can get the energy level. Can you get the wavelength? Let's do one of my favorite. So, as you guys are enjoying some large insects, there are some small ones which have been a problem for a long time, and those are mosquitoes, or what we call mosquitoes, but other people call them mosquitoes. Mosquitoes. Need a really large text. So let's say you're reading for, but the first paper is mathematics, engineering math. Let's not. So you're reading for engineering math, and there's a tiny mosquito which is 1.5 milligrams. That is smaller than a grain of rice. And so you find these two guys saying there's a mosquito there, and one of the students has learned about uncertainty. So your room is about 5 meters by 5 meters is generous, 2.5 meters high, maybe like 2.6. We don't know what length it is. Maybe we can assume it's a square room. So some of the rooms might be smaller. Let's say you paid late, you expected to be coming from home, so you have a slightly smaller room. So there are mosquitoes. These days people have different so they are studying. Of course, some people now are starting to sacrifice their sleep, and much as the mosquito is hoping in that regard, it is still disturbing you. And what is the maximum? Okay, a pesky 1.5 milligram mosquito is annoying you as you study for engineering math in your room, which is 4.8 meters wide and 2.6 meters high. You decide to swat the bothersome insect as it flies towards you, but you need to estimate its speed to calculate a successful hit. What's the maximum uncertainty in the horizontal position of the mosquito? Now, what is uncertainty? The uncertainty principle says that the product of position and momentum uncertainties are to the order of Planck's constant. Or it is impossible to to determine both position and momentum simultaneously to arbitrary position. The limit is imposed by Planck's by the uncertainty principle, which is given by, then you put that equation. So both statements can work. So what's the maximum uncertainty? Now, maximum uncertainty, since we don't have a reference and value, so maximum uncertainty in any quantity so in this one, it's position. I think my handwriting has followed the voice, but so that is delta x. Now we say that this x is to the order of x. That is how we get the maximum uncertainty. So let's have your room drawn out. That is 5 meters, 2.8 meters. Why are we using 5? Isn't that cramming? It's 4.8. So those are the dimensions you have. Now you could, of course, use your imagination that your room is 3D, but one of these other dimensions is not given. So this is still 2.8. So this dimension is not given. So you can make assumptions around it as long as they don't violate the question. So you can assume that this side of the room is maybe the same as this side, so it is square. But maximum uncertainty in position is to the order of the value of the measured value of position. So maximum uncertainty in position is simple. So it's the order of x. That would mean the maximum uncertainty in position is for delta x max. We said it's to the order of 4.8 meters. So which makes it actually 4.8. So here they have asked for maximum uncertainty in horizontal position. So let's say your room is, if you're studying, of course, there's light. So, but let's say you can't see the mosquito anyway. So it's not really dark. But we're saying maximum uncertainty is 4.8 meters. So what limit does this put? What limit does the Heisenberg uncertainty principle place on your ability to know the horizontal velocity of the so delta V, what's the maximum uncertainty in velocity? It's going to be equal to, so from this P is equal to mv, that means delta P is equal to, your mass is mostly fixed, so m delta V, right? Now, how do you know which one is the maximum, which is the minimum? So we know that delta V is equal to h divided by, so if we're dividing through by delta x delta P, so it's going to be m delta x, right? Now, this is the maximum when delta x is a minimum, right? So if you know your exact location of the mosquito, that means your uncertainty in velocity is going to be maximum. delta V is minimum when delta X is maximum. Oh, sorry. I should have shared this other screen. Okay, we'll just recap briefly. Stop presenting that. At least you had the question there. So we're saying that you have your room of 4.8 meters by 2.8 meters. That was the question over there. You are saying that you have a mosquito in this room. Let's represent it by which color? Let's use brown. It's 1.5 milligrams. So that's your mosquito. And it's, you know it is somewhere in the room because most probably it's making noise. So that wasn't 2.8, it's 2.6. 2.6. Let's get the pencil. So we're saying that you can make assumptions of your room. Either you can assume that this is the same dimension as this unknown dimension here. You can assume it's either 4.8 or less. But we said you shouldn't really affect the question. So if you assume more, that means you're going to assume a certain value, which intellectually is also correct. But you should try and keep the question as intact as possible. So you're not assuming new values. That makes for better assumptions than you're trying to change the question. It would, I mean, once you have the assumptions correct, then you answer. We said that the maximum uncertainty in position is delta x. Now, maximum uncertainty is to the order of x. So if you have like 10 to the power 10, 10 to the power 9 is closer to the order of 10 to the power 10, like something like 10 to the power 3, right? But order means they're around the same power of 10. But so we say that delta x max is to the same order as the maximum coordinate. I think they're asking for result anyway. And so that means delta x max is 4.8 meters. And so we say that the next thing is to calculate delta v max from part to a maximum uncertainty in horizontal position no, we wanted to know horizontal velocity. Yeah? So since we have horizontal velocity, now typically we are first looking at m. We say that momentum is m times v, so delta p is m times delta v. So delta v max, or delta v before we maximize it, is going to be h over m delta x. Now we see that for delta v to be max, delta x has to be minimum. So we need to know that if we knew the precise location of the mosquito, our uncertainty in velocity would ideally be highest. But now we are looking for minimum uncertainty in this case because we have maximum uncertainty in position. So now, again, we don't know the uncertainty in velocity is to the same order as velocity in this case. The reason I'm using same order because we don't have any measured velocity. But let's see what happened. So in this case, actually, this is it is a misnomer that is the minimum uncertainty in velocity. No, it is minimum uncertainty in velocity. So, because maximum uncertainty could be much higher. Now, delta V is going to be 6.625 times 10 to the power negative 34. Then you divide this by the mass, which is 1.5 millis times 10 to the power negative 3 kilos. Then times delta X max, which we already said is 4.8. So this will be your minimum uncertainty in velocity. So we do our powers. This 34 minus 3 would be times 10 to the power negative 31. Then the rest is a division. 6.625 divided by 1.5 times 4.8 gives a result of just a moment. 6.625. Usually I would prefer to divide by the biggest value, which is 4.8. So that gives you 1.38. Divide by 1.5. It gives you 0.9201. So 4 significant figures is good. 0. Let's just make sure. 9201 times 10 to the power 31 meters per second. So that is your minimum uncertainty in velocity. So if you say you don't know the velocity by up to 10 to the power negative 31, does this really affect your ability to be able to intercept this mosquito? So this is a very small uncertainty, and it has nothing. Okay, it has very little, extremely little, close to nothing to your ability to be able to intercept this mosquito, what we call to swat it. So is this limitation a serious impediment? Is it? Yes or no? If you didn't know your age by 0.1 minutes, would that be a big reason for you to say that you don't know when you were born? Ronald, thanks for the calculation. Yeah, so it wouldn't be a big impediment for you not to know. So you make the conclusion. So there are more interesting things we can do with this question. We could say we could give it your palm size and then reduce this uncertainty. So if your palm is about 5 centimeters, maybe like 7. So let's say if you have a palm of 6.5 centimeters and you're trying to intercept this mosquito, let's say you've seen it on the wall, it is somewhere on the wall, and you have your palm of 6.5 centimeters. What does uncertainty in position look like? Anyone who can type in the chat? let's say it's very close to the wall and you don't know the velocity. So uncertainty in position is to the order of your palm there. So you ignore the room, so it will become 0.065 meters. So you can get your uncertainty in velocity and then also determine if that is significant. So, but typically for uncertainty for large bodies, you remember that the de Broglie wavelength is very small. So the uncertainty to large bodies is really negligible overall, but you need to put that in context. Of course, as you go to the microscopic world, that uncertainty plays a very big role to the point that you have that duality, or that you have to apply complementarity at some point. The observer becomes significant. But even in everyday life or at the atomic level, that those uncertainties can become significant. Yeah, so we'll end here for today. You guys can do those other questions in your discussions. There was one. Yeah, so maybe from this bit, when you have a certain value like velocity, so you can say that the uncertainty in velocity is almost the velocity. So let's say your velocity is about, I don't know how fast mosquitoes are. Let's say 1.7. Okay, let's say it's a very fast mosquito, 2.7 meters per second. So if you want to know the maximum uncertainty in velocity, this would be it. Your delta V, uncertainty in velocity, is the same order as velocity. So what is uncertainty in position? Uncertainty in position is h over delta P, which is h over m delta V. That means that the minimum uncertainty corresponds to the maximum uncertainty in velocity. So we do 6.625 times 10 to the power negative 34. For those who might be joining us later, these are just other cases. 1.5 milligrams. So we already answered the question, times 10 to the power negative 3 times 2.7. So that's your minimum uncertainty in position, or in this place, I think I've been using the x coordinate. The maximum uncertainty would depend on the minimum uncertainty in velocity. Yeah, so typically this is what you have. There can be as many interesting questions as possible. So yeah, have a good day, a good rest of the day. We're over by a few minutes, but it is beyond our control. So yep, have a good day. There are more people than the seen here. Okay, see you later. See you on Wednesday, actually. Let me first stop the recording.